Regulation 7 is relatively easy to satisfy. The normal technique is to apply insulation, a simple, cheap and effective solution. Conductors can also be placed out of reach, behind a barrier or at height. For example, here in this substation, 400,000 volt high voltage conductors are not insulated except by the surrounding air, but are high enough off the ground for people to pass underneath without danger. There are a number of ways of satisfying Regulation 8. Probably the most common is by having basic protection provided by insulation and fault protection provided by a protective conductor or earth attached to any exposed metalwork. The protective conductor is used in conjunction with a protective device, such as a fuse or circuit breaker, to form a protective measure known as automatic disconnection of supply, or ADS. A second technique used for compliance with Regulation 8 is connection to a common voltage reference point. In electricity systems, it is standard practice to connect transformer neutrals to the general mass of Earth. Therefore, provided this earth connection is electrically and mechanically sound, the earth and neutral conductors in a system should be at earth potential, in practical terms, at or about 0 volts. Equipotential bonding is another technique which is very common. This is the interconnection of all exposed conductors so that if they become charged, dangerous voltages between any of the conductors will not occur. Another very common technique for complying with Regulation 8 is double insulation. The symbol shown here indicates that the equipment is double insulated. The principle of double insulation is that any live conductors of the electrical equipment are covered with 2 distinct layers of insulation, each of which would adequately insulate the conductor. So if one layer failed, the other would be sufficient to protect the user, and the probability of danger arising before damage to the insulation is spotted is extremely low. It is recognised by the HSE that a system operating at extra low voltage, that's 50 volts AC or 120 volts DC or less, is safe in most circumstances. Reduced voltage systems are particularly appropriate for portable equipment, since the risk of damage to the supply lead and equipment is always that much higher. A good example of this technique is 110 volt AC centre tap to earth systems, which give a voltage of 55 volts AC to earth. Although slightly higher than extra low voltage, it is still considered relatively safe. But it must always be recognised that in wet conditions, even this voltage could be hazardous. The use of extra low voltage is also useful in equipment which might have to undergo inspection and test live, such as on control panels. It is standard practice in the UK and ERA to reference the neutral conductor to earth by connecting them together at the main distribution board. If this connection were to become open or high impedance, a dangerous voltage could be produced on the neutral conductor. It's the purpose of Regulation 9 to prevent such an occurrence. Some devices, such as bolted links, are allowed in the reference conductor. The neutral earth link in this distribution board being typical. However, devices such as fuses and semiconductors cannot be relied upon to maintain integrity and must not be installed.